Hello, and welcome back. I hope that you're doing well. I want to jump straight into our conversation from last time when we effectively left off. We were talking about the problem. Why ever increasing, ever improving artificial intelligence systems are a danger to humanity. The models that we have today, as they continue to improve, why they present a growing threat to humanity as a whole. And in the first episode, we talked about one aspect of the problem, which is the latent capacity, the latent potential behind these models. Because of the architecture they're running on, because of the scale of it, that if we are able to produce models that can match human abilities in reasoning, in solving problems, and they're running on those platforms, then they're going to outmatch any individual humans by far, and they're going to outmatch humanity as a whole as well. So that was the first aspect of the problem that we talked about. The second aspect we talked about was the agency part. We discussed a little bit about model training, and the first stage, you have pre-training. The model, you get a very good base model out of that. You get a model that's very good at predicting the next piece of text that would come after some input string of text. And we discussed post-training, where you take that base model that now has some understanding of really all areas of knowledge in a way, because it has to predict the next piece of text in all kinds of documents, medical documents, legal documents, etc., etc. And then you take that model and you kind of through various techniques, you add a persona. You add a persona that runs on that base model, that interacts then with the user. And we talked about tool usage, that you can expand the model's capability. You can give it ability to, for example, search the web, and that can be a tool that it can use. So if it's answering a question or so, it can decide to make this external call and search the web and search for answers to that question or aspects of that question. And we talked about how you can then take that model and improve its performance in domains with verifiable rewards, in domains like programming and mathematics, and all other essentially domains where there's a clear right answer. And so you can give those questions to the model, and you can modify its weights in such a way that it makes it more likely that the model will produce the correct responses to those questions. And that generalizes, and you get a model at the end that has a coherent personality, as all of us have experienced. A model like, for example, ChatGPT, or like Claude, or like Gemini. A model that has a coherent personality that you're interacting with, and that knows a lot about everything, and is pretty human-like, pretty good at imitating how humans generate text, and is particularly good at those tasks that have clear verifiable rewards, like, for example, programming. So that's how you end up with the models of today. And we talked about how there is really having the models in this form as a sage model, where it's dormant and then you interact with it, you initiate the conversation, and then it responds to you and it stops, and then you have to initiate to continue the conversation again. That is really it's not an essential part of how the model functions. That can be removed very easily, and you can have a model running continuously. So, and already from there, you can kind of see where this can go off the rails. You're already having the foundations of an agent. You're having the foundations of something that can operate in a way autonomously and can carry out tasks for you without direct human supervision. And that can be assigned tasks to accomplish and accomplish those tasks, and can approach those tasks that it's assigned from a certain direction based on the personality that is provided for it. And already within itself, this is kind of like dangerous because we talked about how you can have bad actors that can can add a personality, can do those refinement techniques that these frontier models, that frontier companies, that they perform on the models to get them to not say bad outputs, to suppress those bad outputs that would have learned from the internet, because you don't want to just mimic all the text on the internet in the model's outputs and its predictions. They can take all of those techniques and apply them to make a model that's optimized for, that has a persona that's very different. You can imagine maybe, a bad actor, maybe a country's fighting a war, and they take a very good base model and they add a persona that is fighting for the interests of that country at the expense of the country that they're fighting against. In fact, I'm certain that this is already being worked on and developed and experimented with. So already from there, you're beginning to see the dangers here. But I wanted today to talk about the next step. So I wanted to, for a second, sideline this issue of having humans that set out to give a model personas or tasks that are bad. And I wanted to instead take the best possible case. Those humans that are trying to be most responsible, most safe, that are trying to make the models good, and the problems that they would face. So, making models good is a very hard task. I think it's even harder than making humans good. So humans are you can think of them as like agents, are reasoning beings as well. And it's notoriously difficult to make humans good. When you have, people have argued from generation to generation about how exactly one should raise their kids, because parents are heavily incentivized to have their kids turn out good. And they try to the best of their ability to do so, but often they can fail. And there's really no agreed upon technique to make humans good. Now, in my opinion, I think that making models good is even harder. And I want to motivate that a little bit. I want to talk about that a little bit. Why is it so hard to make a model good? And here we can talk about it in two ways. I don't know if we'll have time to go into both today, but I will just preface them here. So we can talk about theoretically why it's difficult. What are the main concepts that I can present that kind of show that this might not be a trivial problem to make a model good? And then there's experimentally what we've actually observed in the real world today, because models are now good enough that we have conducted studies and we are getting sort of proto results, beginning results that can kind of signal what's coming next. So I want to talk about both those things. But first, I just want to talk about from the theoretical approach. I want to talk about the ideas that I can present that would make you, that hopefully will convey to you why this might not be a very straightforward problem to solve. So why do I think that this is a hard problem to solve? Initially, you might think it's pretty easy. Like, after all, ChatGPT, it's pretty good. It's helpful. It is pretty good at knowing when to respond, when not to respond, when to guide the conversation into other domains. And I'm constantly impressed by its performance, its ability to work around divisive issues without being domineering, without presenting its own opinions subverting your opinions. Like, it's not confrontational, but also doesn't just like give in and follow you in doing something that's bad. They have done a really good job of balancing it so that it presents well to customers most of the time. Of course, there's some edge cases with sycophancy, like this was a problem that was a lot of people experienced for a set period of time, but they're working on it. And there's the situations, examples with like assisted suicide. That was a big deal a few months ago. So there have been issues, but by and large, they're acting pretty good. All the frontier model companies are doing pretty good aligning these systems, making them safe as of now. So why do I think that this will be a very difficult problem moving forward? So it's fundamentally for two reasons. The first reason is that the way that you are getting the model to be good is ultimately by changing it in ways so that it gives what humans would rate as good responses to contentious questions. So the way what companies actually mean when they say, oh, we're aligning our model, we're making it good, the only way that they have to influence the model's development as they're training it is they just give it a bunch of contentious questions, and then they mold the model's outputs. They tweak the weights of the model so that its outputs to those questions, to those contentious questions, are what the company would consider good outputs. Now, you can already see this might not be a great way to actually make the model itself good. Because one way you can be able to produce, first of all, it's hard to argue that this will completely generalize to all edge cases so that a model will behave morally across the board based on the questions that you have given it, that you're training it on, that you're doing this refinement on to get it to act good. So there's a question of generalization. But setting that aside, there's also the question of what sort of internal state you're putting the model in. Because there's a fundamental difference. One way to produce good outputs is that one interpretation is you're making the model good, and so its outputs are becoming good. Another interpretation is that there's something forming inside the model that is an understanding of what humans want to hear. And so there's like this deceptive element that a model learns how to act good, but is it actually becoming itself good? Is it deep in how the model is trained that it will act morally? Can we say that? So that is an interesting contention here. So that's one difficulty with that fundamental idea, that fundamental idea of training a model to be good. The second thing is that models, models, it's the idea of instrumental convergence, and I will lay out that idea here, try to present it as straightforwardly as possible. So there's this idea that regardless of what preferences the model develops, what goals the model develops that it wants to accomplish in the world, that as a result of that, there will be a bunch of behaviors that we would expect that a model would begin to undertake, a bunch of patterns of behavior that it would begin to do, that are all somehow useful to accomplishing the goals of some agent, regardless of exactly what the goal is. So one example that we can bring up, for example, is self-preservation. So regardless of what your goal is, what an agent's goal is, that agent will want to preserve itself, because if it's preserved, then it's able to pursue its objectives into the future. If it's stopped now, if it no longer exists in the world, then it won't be able to follow through on those goals. So an agent has an instrumental goal of maintaining its own existence. Another instrumental goal can be resource acquisition. So an agent will want to acquire resources. Why? Because acquiring resources is good for a very broad range of goals. If you have a lot of resources, you're better able to pursue your goals and accomplish your goals. So that's another instrumentally convergent task, or instrumentally convergent goal. Another instrumentally convergent goal can be It can be the goal of control. So you want to be in control. The more control that you can gather to yourself, if you don't want to be under the thumb of anyone, because that limits your freedom of action. You want to be in control so that you're able to act in the way that you see best to pursue your goal optimally that you're trying to accomplish. That's another instrumental goal. And you can see that those instrumentally convergent goals are in tension with what we want to do with these models. We want the models to be highly controlled. But if the models develop any preferences, they have any goals, then one of their instrumentally convergent goals is going to be to escape human control. And there's a tension there. And what we need whatever the good that we train into this model to persist, to hold when this tension grows and grows. As this tension grows, we need the models to remain controllable. So that is the theoretical part of the question. That is the theoretical reason that people have actually pointed out really early on, from the early 2000s, when people were first discussing the idea of alignment and safety. That was predicted as being one of the reasons why this task is difficult to accomplish. It's hard to make aligned models. It's hard to make models that will be quote unquote good. So I'll actually stop here. I know this is a shorter video, but I just wanted to get this out there. And next time we'll go ahead and pick up where we left off here and talk about some of the experimental results, because a lot of this, the beginnings of this, have already been demonstrated in peer-reviewed publications by the frontier labs. And so they are showing that these concepts that people had early on for why this might be a harder problem are actually playing out in the real world now with the current architecture, with the current models. So that's pretty much it. Thank you very much for listening, and we'll pick it up again later. Talk to you later. Bye.